Hello AP Chemers, this is the Worksheet 1.A.1 and number 1 asked about the percent hydrogen and oxygen in water. So I added up the molar mass. I added up the molar mass by taking 2 times 1.01, getting 2.02. For hydrogen, 1 times 16.00 because water contains 1 oxygen. And then I got 18.02 for the overall mass of water. So my percent hydrogen is the part over the whole, 2.02 over 18.02, which is, don't forget to multiply by 100, 11.2%. The percent oxygen, 16.00 over 18.02 is 88.79%. And I did try to do significant figures here. In AP Chemistry, you always want to do your masses to the hundredths place. Now, I know in Chem 1 we did masses to the tenths place, but in AP Chemistry we could do masses to the hundredths place. So, number 2, asking for the ratio in decimal form, the ratio of hydrogen to oxygen, 2.02 to 16, is 0.1265. I guess that would actually be 0.127 probably because they're 3 sig figs. Something else about sig figs, AP Chem will overlook a plus or minus 1 sig fig. So in this case where maybe I was supposed to have 3 sig figs, having 4 will not count against me. Having 5, they would frown on that and maybe take off points. But as long as the answer should have 3 sig figs, they will allow for 2 or 5, or 2 or 4 rather, in the final answer. Plus or minus 1 sig fig allowed on AP test. Number 3, comparing water to hydrogen peroxide, which has a formula of H2O2, we do the same math, get the percent hydrogen and oxygen. 2.02 and 32 make 34.02. 2.02 divided by 34.02 times 100 is 5.94% hydrogen, 94.06% oxygen. Number 4, finding the ratio in decimal form by taking 2.02 divided by 32, I get 0.0631. Now number 5, I'm going to divide the 0.1265, the decimal ratio for water of hydrogen to oxygen, to 0.06 by 0.0631, the ratio for peroxide, hydrogen peroxide. And I get to 3 sig figs, 2.00. So what this illustrates is that law of multiple proportions. The ratio of hydrogen and oxygen in water and the ratio of hydrogen and oxygen in peroxide are in fact a whole number ratio themselves. So Dalton, noticing that, called it the law of multiple proportions. That one proportion is a multiple of the other proportion. Okay. Now looking at number 6. On number 6 we are practicing finding the average atomic weight from the percent and mass of each of the isotopes, the percent abundance times the mass of each of the isotopes. I like to change the percents to decimals. So 7.59% is 0.0759. Multiplying by all the digits in the mass of the first isotope, percent of the second one in decimal form times all the digits in the second isotope. Now, multiplication, order of operations comes first. Do the multiplication and round to 3 sig figs, 0.457, because 0.0759 had 3 sig figs. Do the multiplication and round to 4 sig figs, 6.483. Now, the next order of operations is addition. 0.457 plus 6.483 is 6.940. I believe the periodic table gives 6.941. But remember, in addition, even though this has 3 and this has 4, This goes to 3 decimal places. This goes to 3 decimal places. So the answer goes to 3 decimal places. Okay. Number 7 is asking what element would have an isotope that weighed 63, 62.929601, and an isotope that weighs 64.927794. So that would be 63 and 65 would be the isotopes. So that would have to be copper, because on the periodic table, only copper shows an average mass between 63 and 65. So there's only one element that it could be, and that would be copper. Now, the average atomic mass on the periodic table for copper is 63.546. And 63.546 is closer to 62.929601 than it is to 64.927794. So that means the lower mass isotope contributes more to the average. So this must be the more abundant isotope. Copper 63 must be the most abundant isotope. Okay.